Good afternoon and welcome to this year's Orkney Aviation Festival. It's organised by a team of really committed people, AOP, standing for Another Orkney Production. Over the years, they've provided a wonderfully varied mix of topics and activities. And in this, their second year online, we're delighted and honoured at Orkney International Science Festival to provide the online hosting for them. And this afternoon, they're looking into the future of aviation, and in particular, a project in Orkney that looks set to give us some clues as to what that future may hold. It's called the Sustainable Aviation Test Environment Project, SATE for short, and its aim is to try out methods of reducing carbon emissions from aviation. That means, for example, hybrid aircraft using electricity from batteries or from hydrogen from renewable sources or sustainable aviation fuels. It also means using drones to supply on-demand medical supplies to health centres. Well, with us, we've got three people who are at the heart of the project. There is Dougie Cook, who's General Manager North for Highlands and Islands Airports. In fact, he's been working with Highlands and Islands Airports, I think, for 27 years, based at Wick, John O'Groats, and now covering Kirkwall as well. Professor Andrew Ray is Chief Engineer at Ampaire, who've been providing a hybrid electric aircraft to go into action at Kirkwall. Andrew worked in industry for more than 20 years, and in 2010 he moved to academia, and he's Professor of Engineering at the University of the Highlands and Islands. And Herman Moreno is the Head of Flight Operations at Windracers, an organisation established to use drones for work for public benefit. There will be an opportunity to put questions to them through YouTube's live chat, and we'll be able to come to these at the end of their presentations. But now it's time to hear from, first of all, Dougie across in Wick. Welcome, Dougie. I'm looking forward to what you've got to say.
Thanks very much and good afternoon. Good afternoon, everyone. So I'm primarily here to speak about the Sustainable Aviation Test Environment and the history surrounding it and where we are currently. Next slide, please. So yeah, I'm Dougie Cook. I have the title of General Manager North, and I work with Highlands and Islands Airports, who are the lead partner in the Sustainable Aviation Test Environment. Next slide, please. The consortium and the funding. So where did the SATE project come from, and how did it come about? It's part funded by the UKRI, the UK Research and Innovation, and that's through the Industrial Strategy Fund Challenge. It's the Future Flight Challenge, and they are investing up to 125 million to develop greener ways to fly, such as all-electric aircraft, deliveries by drones, advancing electric and autonomous flight technologies. And this investment has been matched by industry, and it's 175 million that they're putting in. Challenge aims to bring together technologies in electrification, aviation systems, and autonomy, and to create new modes of travel and capability to make flight more sustainable into the future, more economical, greener, and just better for the end user. Consortium partners, so as I mentioned, Highlands and Islands Airports Limited, are the lead partner, and HIAL operates Kirkwall Airport on behalf of the Scottish Government. So we have HIAL, some of our other partners. We've got Windracers, who have an autonomous vehicle, Zero Avia, who have a hybrid hydrogen aircraft, Ampaire, our hybrid electric partner, Flarebright, who are operating a small drone aircraft, and another number of other partners from academia, Orkney Islands Council as well, and CloudNet. So there's 13 partners in total. Next slide, please. So what is the objective? What was behind the SATE project? And it's to create the UK's first operationally based, and that's the bit that's really advancing technology, is that it's an operationally based airport. It's a commercial airfield. It's not done in a completely test airfield, and it's to make a low carbon aviation test centre at Kirkwall Airport in the Orkney Islands in Scotland, and overall to help decarbonise the aviation industry, not just for Kirkwall or indeed the Highlands, but for the UK as a whole. And the project features flight trials demonstrated in a real life context. So working at a real airport, having to integrate with other commercial flights, oil and gas, inter-islands flights at Kirkwall, flights back to the mainland, and also emergency flights. Trials including low carbon aircraft using electric, hydrogen, and sustainable aviation fuels, or SAF, as well as our unmanned autonomous vehicles. And the other big part that I've really been involved in is the airport infrastructure improvements. What do we need to put in place at Kirkwall to make this test environment and make it suitable for these aircraft to come and do their trials? And eventually the goal will be to improve regional air connections, and see what impact it is on the local supply chain. What does the airport of the future look like that is more sustainable? And what do we need to put into it? And then ultimately to contribute to the net zero aviation goal from the Scottish Government by 2040. Next slide, please. The innovative aspects of the Kirkwall test environment. So it'd be based at Kirkwall. As I said, it's a busy multi-use operational airfield. Activities should include the scheduled inter-islands, island mainland, helicopter ops, international traffic. In the year 2018, 2019, we had 190,000 passengers come through Kirkwall Airport and over 14,500 movements. So it is a busy, small regional airport. A set of industrial and community-based use cases in the real world for alternatively fueled and alternatively piloted aircraft. It is so at the end of this project, what can we demonstrate in real life contexts that can help? And that would be improving inter-island services, inter-island mainland services, the UAV operations and feasibility. And we're going to be doing some test cases as well around providing support to mail, healthcare, and the oil and gas sector. Implementation of all of these cases is going to require advances in technology, legislation, regulation, and policy. And we've closely worked with the CEA in something called the Sandbox for Innovation. And that is to help move regulation on to incorporate these new different types of flight. The project has road mapping reports, technology certification to exploit future flight offers to the regional communities. What does that mean? It means that there are targets and goals that we have set for ourselves so that we can measure how successful the project is. And there's a contribution to decarbonising aviation across the globe, providing lower cost operations to the customers, which is the flying public, and to explore new applications, brand new ways of using aviation to make everyday life better. And we want to develop a test environment that has the correct physical, digital, and operational infrastructure necessary. And that will be an ongoing process. At the moment, we are in the process of putting the infrastructure together, but we need to know now what the digital requirement will be and how do we integrate these new test flights into everyday operations or business as usual. Next slide, please. The visualization that you can see on the left is our eventual site and what it's going to look like. So that is the vision, and the one that you can see on the right is actually where we are now. So what you can see in the biggest part of it is what is called a RUB hangar. It's made by a company called RUB, and that will house our aircraft when they're at the test environment. We've also included an apron and a taxiway in front of it to get us into the existing services. And we've provided office space and car parking for all of the partners that are going to come and test with us. And also we've had to upgrade some of the supplies. So the electrical supply to this side of the airfield has been upgraded. And also we're going to be putting in services to allow hydrogen production at a future date. And at the moment, I am actually sitting in the offices at the SATE site. Next slide, please. And that is it. That's a very quick run through of how we got where we are and where we are currently. And work is progressing at pace on the SATE site, and hopefully HIAL will be taking handover of a lot of the areas at the end of September and then into early October. Thanks very much.
Oh, thank you, Dougie, for setting the scene for us. And now we'll find out about some of those electric hybrid flights that have been taking place. And Andrew Ray is going to tell us about them.
Thank you, Howie. Yeah. So yeah, thank you very much. I hope you can hear me okay. So as Howie introduced me, I'm the Chief Engineer for Ampaire, and we are one of the partners in the SATE project and completed our flight testing in Orkney recently. So I'm going to describe the road to that flight testing that occurred last month. Next slide, please. So some of you have seen the aircraft already. It's been to Kirkwall a couple of times, and it's a modified Cessna 337, the front engine of which has been replaced by an electric motor. And it's the second incarnation of that aircraft. Previously, we replaced the rear engine with electric motor and kept the internal combustion at the front with the battery inside the cabin. So this aircraft now has the battery in the big gondola you can see underneath the fuselage between the wheels there. Obviously photographed on a beautiful Orkney day. Next slide, please. So this gives you an idea of the electric motor at the front. So there's very little to it. The black block behind the spinner is the electric motor. Then we have the control electronics, the inverter, and the cooling system. And as you can see from the pictures on the right, once you take the internal combustion engine out and put electric motor in, most of the volume is left unused. It's a much smaller volume requirement. That also has an issue with the weight. So we had to put some ballast plates in the nose to keep the weight and balance of the aircraft correct, because obviously the electric system weighs much, much less than a big block internal combustion engine. Next slide, please. So the development of the aircraft started off with the choice of the aircraft for the Cessna 337. The reason for that is it has twin engine safety, but a single engine failure doesn't result in an asymmetric thrust case. So if the front or the back engine fails, the thrust line is still down the center of the aircraft, which means that it's much more controllable than a side-by-side twin engine like the Islander would be. So we went through a series of phases, the first of which we called a copper bird test, which is the test of the electrical system. And then once that had been successfully demonstrated, put that into a representative fuselage and aircraft representation before putting it into an aircraft that would be ready to fly.
I'm just wondering if we could have lost an internet connection there. To see if Andrew's going to. I know that Andrew's in transit somewhere between Kirkwall and Southampton. Yes, I think he's lost. Hopefully Andrew's not lost, but it's just the internet. We'll wait a moment, and if needed, we'll go over to our third speaker, Herman Moreno, and then we can catch up again with Andrew when he gets back. I think that just waiting for a message. Yes, Andrew has gone. So Herman, it's over to you. You're promoted in the running order. We're looking for Herman to tell us about drones, the drone operation, and how it's working and what its prospects are. So over to you, Herman.
Okay, good afternoon. Thank you, Howie, for the introduction. And yeah, hopefully we have Andrew back soon. So in the meantime, I will tell you about the operations that we have planned within the framework of SATE project. Windracers have planned a number of UAV operations in the Scottish Isles. It includes both the Orkneys and the Shetland Islands. Next slide, please. So first, I would like to tell you a little bit about Windracers and how we came about to build and operate this UAV. So first, the founders of Windracers back in 2017, they had an inspiration looking at the case of South Sudan and other places in Africa where civil war and flooding has deteriorated all the supplies of essential goods to the population. It is estimated that in a case like South Sudan, about 7.5 million people require humanitarian assistance. This is in the way of food rations or humanitarian relief items. And this is currently done either using roads or using airdrops with this like big Antonov aircraft, and logistics that are quite costly. So looking at that problem, they thought, well, we can resolve this using unmanned aircraft systems or drones or how they're called currently, uncrewed aircraft systems. So they approached the University of Southampton, which is the leading school in the UK for unmanned aircraft systems, and then the university started working on designing a conceptual UAV fit for this purpose. So next slide, please. So to begin with, a little bit about what are the benefits of UAS distribution. So I think there has been a lot that has been discussed about what the benefits of using UAVs, basically of not having the human pilot co-located with the aircraft. But when it comes to distribution, the main benefits comes in cost, mainly due to automation, fuel consumption, and the way it can have a widespread distribution very quickly. So say in the case of Ultra UAS, which is the vehicle that we operate, currently we have 2 people crew on each location, but we're working on reducing that to 1 person, thus reducing the human cost and the workload on operating. And also the fact that we are not carrying a human on board, a pilot, that has reduced massively the consumption of energy that is required to fly that payload. Next slide, please. So when the requirement was given to the University of Southampton to design and build this aircraft, the main requirements were to be able to carry at least 100-kilogram payload at a distance of 1,000 kilometers. Of course, that something that could be highly reliable. That means something that could enter an airspace like the UK airspace, which is not easy because it has the UK CAA is looking after really good safety standards. Also, a system that has redundancy of all critical flight systems like propulsion and flight control systems, that is easy to maintain, due to logistics in these areas where we want to operate, like places like Africa or islands that are not well connected, that has a small ground footprint that doesn't require a lot of equipment on ground to operate. And finally, that can operate from short, unprepared runways or basically any field. Next slide, please. So on 2019, we first flew what we called Ultra TD1, which was the first generation of Ultra UAVs. Currently, we are operating the second generation, which we started operating at the beginning of 2020. So the specifications of Ultra TD1 has a wingspan of 9.7 meters, more or less the size of a small manned aircraft, a small Cessna or a C-42 aircraft, an empty weight of 285 kilos and maximum takeoff weight of 400 kilograms. This current version has a fuel capacity of about 30 liters, but we are working on a wet wing version that will have fuel capacity of between 70 and 90 liters. In total, we have reached our goal of the 100 kilogram payload mass. This fits in a usable volume of 700 liters. And with the work that we've done, we have realized that in many of these logistics missions, what it is important is about the volume. So 700 liters of payload, this is more or less the volume of the boot of a state car. It cruises at 75 knots and consumes just a third of the fuel of one small aircraft, manned aircraft of the same size. So about just less than 10 liters an hour. We're talking about a Cessna 172 can consume over 30 liters an hour. And it's been prepared and designed for harsh wind conditions, total wind 40 knots with a 20 knot crosswind component for takeoff and landing. Next slide, please. So about the reliability and the maintainability of the system. So we have designed an aircraft that has redundancy of all critical subsystems. So as you can see, it's twin engine, and if one engine fails in flight, it can continue flying with one single engine. All the control surfaces have been divided in several segments, so that if one of the segments or one of the servos driving the same segment fails, then the other segments can take over and continue providing the control of the aircraft. We have also an in-house designed health monitoring system that is sending telemetry of the health of the aircraft at all times to the ground control station and telling what's happening with the aircraft. Say if one servo was about to fail and it started consuming more electrical load, then the operator on the ground could tell at any point that is occurring and make decisions upon that. Something that we also take proud on is in our flight control system, which doesn't have a single point of failure. It's a triple redundant flight controller, and it operates a number of sensors, both for GNSS navigation, airspeed, and inertial sensors that are shared between all flight controllers. And then the signals of control are sent to different actuate nodes that act kind of like as discretized arbiters of those signals to make sure that if one flight controller fails, the aircraft can continue flying without compromising the safety of the flight. Also, we have provided the system with over-the-internet control. That means that the operator of the aircraft doesn't need to be co-located with the system. An aircraft flying in Kirkwall can be operated from by a person that is located here in Southampton or anywhere in the world. And the aircraft is weatherproof, so all electronic and critical systems have to be enclosed in IP-rated enclosures to make sure that it can fly in rain or other weather conditions. Next slide, please. More things that we have in the development pipeline. So we saw about Ultra TD2, but there are more versions that are being worked on right now, both designed and built. We work basically on 5 different branches. One is automation, With the automation side of things, we are aiming to reduce the amount of workload and the amount of people that is required to operate one of these systems. So we want to get to a point in which a person on the ground only needs to check that the runway is clear and then decides, okay, you can land. But that person doesn't need to have special skills or make more discrete decisions on how the aircraft navigates or flies to that location. We are also improving on communication. So in November this year, we're gonna deliver something called cloud control that will allow us to control the aircraft using other communication channels like 4G communications and beyond radio line of sight, like satellite systems. Performance-wise, we're always working on this, increase the payload and range, that's the main thing. And there is part of the team that is looking into alternative modes of propulsion, so moving from fossil fuels into electric and hydrogen engines. One of the main tasks for us is pass regulation, pass all the regulations to be able to fly beyond visual line of sight in unsegregated airspace. So currently, when we fly beyond that visual line of sight, we have to set up temporary danger areas, and we know that is a burden to other airspace stakeholders, because that creates virtual walls where they cannot fly during the activation periods. So we currently are working on Detect and Avoid, which is right now fed by electronic conspicuity, but we hope that in future we can find other ways to be collaborative with all the traffic. And the fifth branch is data. So it's basically when it comes to UAVs, these are very data-rich systems. So we have a lot of data that is coming through the telemetry channels. There is a lot of data, flight data, that is stored in the system itself. And it's how do we exploit it to make flight operations and maintenance operations more easy using APIs and user computer systems. Next slide, please. Now I'd like to talk about a little bit of the work that we have done, operations that we have completed. So during the first lockdown in April 2020, we did the first point-to-point BVLOS operation that a civilian drone has done in the UK. It was a relatively short flight between Lyon Solent and an airfield called Binstead in the Isle of Wight. It's about a 12-kilometer flight, but it was a really big milestone for, I would say, for all the UAV industry. We were carrying payloads of about 40 kilograms, occupying 700-liter volume. So the picture that we see here on top left, Professor Cherrett is here loading some boxes for the NHS. Something that we learned from there is that about how the NHS carry their samples and medicines using these foam blocks these foam boxes that really are not that heavy but occupy quite a big volume. And that's when we realized that that requirement of having that big volume has been very beneficial for the operation. And again, this was a world first, this point-to-point operation. Next slide, please. Following that, we moved into a longer point-to-point operation. The first time that we went and landed with the TD1 system on the Isles of Scilly. So that was December 2020. The flight is over 27 nautical miles of water, crossing between Land's End and St. Mary's. We completed the return flight in just about an hour, carrying 50 kilograms and 500 liters of payload, and it was completely autonomous from takeoff to landing. Next slide, please. So after that successful first flight to Isles of Scilly, we continued working there. And then earlier this year, we carry out an operation that is very similar to what we want to do in the Orkney Islands. So this is what we call the Isles of Scilly Air Bridge. So for a whole month, we did scheduled flights Monday to Friday, starting every day, taking off at 6 a.m. And we had the requirement to be landed back at Perranport before 8:15, just to make sure that we didn't have any conflict with the commercial flights that run from Land's End to the Isles of Scilly. And we actually managed to deliver all these flights over those 4 weeks, completing 211 kilometers flight distance every single day, carrying payload for Royal Mail. So we were every day at around 5:30 a.m. putting bags of a whole York of Royal Mail cargo into the aircraft and sending it to the Isles of Scilly, and then bringing the aircraft back. We had a really limited time window for return flights, and we delivered with no issues. Next slide, please. So now I would like to talk about what we're going to do within the framework of SATE. So the idea is to connect mainland Scotland with the Orkneys and the Shetlands. So at the beginning of this project, first thing we did was start looking for use cases. So who would benefit from this? And to be honest, the response was amazing. It was really good to talk to people from NHS, to people from Royal Mail, to people from the industry, people that would like to be able to send their products and everything that is produced in the Orkney Islands to mainland to be transported quickly to be sold somewhere else. So first, we identified a number of use cases, and with those cases, we started designing a few routes. And although we would like to go to every single island, we had to limit the scope because of regulations and because of really currently we don't have that many crews that we can locate in every single of these points to be able to do this. So we're going to be doing long-range autonomous BVLOS flights based at Kirkwall. We're going to be there at least for a month, initially doing flights between Kirkwall and Wick. Then we will be operating routes for Royal Mail to North Ronaldsay and Fair Isle. That's going to happen in October this year. And then later on in March next year, we will do a second phase, which will connect Kirkwall to Lerwick and to Unst, which is the most northerly airfield of the UK. That would be the longest segment of flight, about 400 kilometers out. Next slide, please. A little bit of how do we do with the whole regulation on this. So as many would know, beyond visual line of sight in Class G airspace are not allowed currently in the UK unless you have like a certified detect and avoid system. But that is still a technological challenge for many people that have been working in the industry. So we're going to be using these structures of segregated airspace. We have designed a schedule of flights that aims to use these segregated airspaces at the minimum possible, so that there is the activation of these segregated airspace structures is just at the minimum time, and not many people get affected by it. Also, we have received lots of help from air traffic services. So Kirkwall Air Traffic will provide danger area activity information services for segments Alpha and Bravo of the TDAs, and Somber Radar will provide danger area crossing services to segments Charlie, Delta, and Echo. Next slide, please. Okay, so as I was telling you, this is how the SATE operations are going to be. Between the 27th of September and the 24th of October, we will be operating in the TDAs Alpha, Bravo, and Charlie, connecting Kirkwall to Wick, then to North Ronaldsay, and finally to Fair Isle in return flights. And then starting March next year, we will be going between Kirkwall and Lerwick, and finally to Unst. The aircraft is equipped with electronic conspicuity, ADS-B out, and Mode S transponder. So there is a very high likelihood that anyone interested can follow the flights using Flight Radar 24. Next slide, please. Well, this is it. I think the next slide shows you a little bit of a video of one of the flights between Perranport and the Isles of Scilly. So this is an onboard camera that we have mounted on the tail of the aircraft, and that allows us to just see what's happening during the flight, because this is not something that is streamed during the flight to the ground. So we were taking off at 6 a.m. with crosswinds of up to 20 knots, and we were crossing over the sea in about 45 minutes, getting to the other side. So this is a little bit of how an operation looks like. So this is an automatic takeoff, and then we fly very close to the airport of departure for a few minutes until we do all the checks and make sure that the system is behaving nominally, and we get all the clearances of the air traffic services before we can send the aircraft into its normal route to the other side. This route specifically, we were basically departing Perranport at 800 feet and then climbing out to 2,000 feet. I don't know if we can skip a little bit. This is the arrival to St. Mary's. So this is St. Mary's Airport in the Isles of Scilly. Again, an automatic approach to the Isles of Scilly, as you can tell by the movement of the aircraft, and it was quite a windy day. I think we had about 25 knots, about 60 degrees off the heading of the runway, and the aircraft actually behaved all right. And also, as you will see in the video, like takeoff and landing occurs in really short distances. We're talking about being airborne in less than 200 meters, and pretty much the same to from being airborne to come to stop in a landing. So, well, I hope this gets you excited about the project. In the end, our participation in SATE is not about testing a new aircraft, a new system, because this aircraft has been tested and the system has been proven. But what we'd like to understand now is how we can identify those infrastructures that we need to be able to deploy the system more actively and be able to help into the supply chains of the Orkney Islands. Well, thank you very much, Howie, and up to you.
Well, that is fascinating, Herman, and it's been stimulating some questions that have been coming in, and we'll look forward to those at the end of the presentations. But now I have good news.
Perfect.
Andrew has found a situation where the internet problems are resolved, and here he is joining us. Andrew, you are most welcome.
Thank you, Howie. Yeah, I could claim that it was on purpose to demonstrate what Dougie was saying earlier on about digital resilience. It's annoying enough when a webinar doesn't work properly. It's catastrophic when it doesn't work on an aeroplane. Anyway, back to the presentation. So I mentioned there was an evolution of the test beds. The first one being the copper bird. So here we just have the electrical system driving a motor with a representative propeller on it. But the important thing here is the creation and testing of all the control systems to make sure that the battery is okay, that the motor is okay, and that it functions as it should do. Next slide, please. So once we were satisfied that that was okay, we got an old time-expired Cessna 337 fuselage and put everything into it. So the first iteration on the left was the rear electronic propulsion unit, and the second iteration with the front EPU on the right-hand side. So that's to make sure that we can integrate it into the structure, so that we can run cables where we want to, where we can get sensors where we want to, and all that sort of practical stuff. So that was the Ironbird testing. Next slide, please. So here's it's further on. So the silver box at the bottom there is the battery pack that sits in the gondola underneath the aircraft. And of course, one of the things that we had to make sure was that the flight crew, the test pilots, were able to get the right amount of information to be able to look at the aircraft and its performance, and especially the new EPU, and make sure that it was functioning correctly. So quite a bit of work went on the cockpit display to make sure that the pilot was comfortable that they had enough information to fly the aircraft safely. And we used 2 pilots from a company called Wasabi Flight Test, who are based in Mojave in the US. Next slide, please. So the first major series of test flying happened in California, between Camarillo and Hayward. So 24 flights over a period of 28 days, just over 33 hours of flight testing, and we had no failures whatsoever. At that point, we'd covered longest distance was 341 nautical miles in 2.5 hours was our longest electric flight. Next slide, please. So one of the things that we're interested in, and one of the reasons we came to Orkney, is to test it on real-world airline routes. So the aircraft next went to Hawaii to work with Mokulele Airlines, who fly in and to the islands in Hawaii. So again, we did another 20-odd flights over 17 days, over 20 hours, and again, 100% dispatch reliability, so nothing went wrong. Next slide, please. So then Ampaire joined the SATE project, as Dougie has described. We brought the aircraft across to the UK in a shipping container. It arrived at Wick on the 20th of July. We put it back together again with some of our Ampaire colleagues. And that was reassembled by the 4th of August when local checkout flights were done at Wick. And then the first flight between Wick and Kirkwall occurred on 6th of August. And on the right-hand side, there is a still from a video from one of the air traffic controllers at Kirkwall as the aircraft departs Kirkwall on that first arrival. Next slide, please. Thank you very much. So we did a couple more return flights. We didn't land every time. So there's a view of, on the right-hand side, a view of Kirkwall from the aircraft as it returned back to Wick. And it's fair to say that the weather got in the way a bit, but that's what we were there for, to see if the aircraft could cope with that kind of conditions. And there's the aircraft on the left-hand side outside the fire station at the event we had in Kirkwall Airport. Next slide, please. So once we'd finished flying within the SATE program, the aircraft was transferred south to fly in another of Ampaire's projects under the Future Flight Challenge project called 20. We had intended to fly directly from Wick to Exeter, but the problem with one of the existing bits of hardware on the aircraft, the transponder, forced us to land at Perth for that to get replaced. And then the aircraft flew non-stop from Perth to Exeter. So that's a distance of 400 nautical miles, 418 nautical miles, breaking our own previous record. We then did further testing between Exeter, Newquay and Land's End. So we literally flew between Land's End and John O'Groats and beyond, of course, to Kirkwall. And on the right-hand side, there's a few shots of the aircraft at Land's End flying out over the north coast of Cornwall and returning back to Exeter. So next slide, please. So in a slight segue away from modern technology, I just was asked to present a little bit of a personal connection to the project in Orkney. And for those of you that are more aviation anoraks, it's maybe more of a collection of pictures that might be interesting, hopefully. So my grandfather was John Ray, who was a senior pilot for Highland Airways in Orkney between 35 and 37. That's him standing in front of the one of the de Havilland Dragons at Wydford Aerodrome, which was used prior to the creation of the current Kirkwall Airport. Next slide, please. So I think that's probably St Magnus's Cathedral spire in the background. So that's my grandmother and my uncle in the pram. So he was at the time the youngest person to fly on Highland Airways. Next slide, please. And many of you who are familiar with aviation around Orkney will be aware of the crash of the Dragon at Russia in September 35. My grandfather was flying at the time. He said he was flying into a headwind and the headwind stopped and the aircraft just dropped like a stone. Unfortunately found a copse of trees, which is quite an achievement in Orkney. So the aircraft was quite badly damaged. It was transferred back to Kirkwall by boat, but apparently was flying again in 3 days afterwards, so quite an achievement. Next slide, please. So the route my grandfather took there, he was an apprentice at de Havilland's down in London. Bottom left-hand side, that's him winning the slow bicycle race at the de Havilland Sports Day. He then learned to fly within the RAF Volunteer Reserve. Next slide, please. He was then sent to Chile for 6 months to reassemble and air test some de Havilland Moth trainers. He'd become a test pilot by then. So, after aircraft had been manufactured or assembled, he would fly them out to make sure they were okay. So he spent 6 months in Chile doing that. Next slide, please. Before leaving de Havilland's, he moved to Midland Scottish Air Ferries. So he delivered a Dragon to John Sword at Renfrew, and John Sword offered him a job. So he spent 2 years having just got married to my grandmother, and they lived in a caravan in front of the hangars. You can see in the bottom left-hand side there. So that was their first marital home, with a meteorology station just outside the thing that looks a bit like a beehive. And on the right-hand side is the fleet of Midland and Scottish aircraft outside the hangars at Renfrew. Next slide, please. So with him at Renfrew were a couple of quite notable aviators. On the right-hand side there, in the middle is Winifred Drinkwater, who became a licensed engineer at the age of 17 and a pilot not long after. On the right-hand side is Jimmy Orrell, who later became a test pilot for Avro. So the important thing for these pilots at the time, because it was so basic, was that they had to navigate well, and they had to know how to fix an aircraft. So all the pilots were also licensed aircraft engineers. Next slide, please. So after leaving Midland and Scottish, he went to de Havilland's again and was sent out to Zimbabwe to set up de Havilland's office at what was Harare Airport, and created the airport there. So that on the left-hand side is de Havilland's office in Zimbabwe. I don't know whether you can make out, but in the middle picture, there is a swarm of locusts in front of the hangar. So the white dots against the black background is locusts trying to find anything that to fill their stomachs. Next slide, please. So that's the hangar they built at Harare, and it puts me in mind of Dougie, of the SATE hangar that we've had built recently. So that frame on the left-hand side was pretty much how I saw it when we left Kirkwall a month ago, and from the picture you've just shown, the middle picture now is more like the representative one there. But on the right-hand side, you can see how much in the wilderness the airport was there. Next slide, please. So he also spent 18 months at Croydon as an air traffic controller. An interesting time. So it had some interesting airplanes arrived from sort of the past in terms of the HP-42 on the right to the future of the Condor on the left, and on the left-hand side of the right-hand picture is the de Havilland Albatross, which in my opinion is one of the most beautiful aeroplanes ever designed. Next slide, please. He then joined the RAF at the outbreak of war and became a navigation instructor on Anson's, starting off at Blackpool, and then next slide, please. Moving across to Canada and to Trinidad. So some slightly different variations in weather conditions, from lots of snow to lots of sun, before being brought back to the UK to fly Dakotas as glider tugs on D-Day, Arnhem and the Rhine crossing, getting shot down on D-Day, ditching in the channel and getting picked up and returning to flying. Next slide, please. And then he finished his career in the commercial world again, flying for Hunting and for British European Airways. So from some of the pioneering air routes up in Scotland to sort of mainstream airline routes after the war. And I guess that's kind of the journey that we hope that we are on with these new types of aircraft. From the pioneering work that we're doing now, they'll become part of the mainstream in the not too distant future. So next slide, please. That's me. Thank you very much indeed.
That is fascinating and wonderful to see your grandfather, and indeed hearing the account of these developments and projects that are underway at Kirkwall Airport. I did have the feeling very much that there was something of the spirit of Captain Fresson and Highland Airways about the new projects. But now questions have been coming in, so if I could welcome all three of you, that's Dougie and Herman and Andrew. And I'll start, in fact, it's two questions, Herman, that have come for you, both about what happens in difficult weather conditions. Susan Timmins asks how Windracer drones would cope with such conditions, and Pentland 284 says, what happens if one of them can't land at the designated place?
Okay, thanks, Howie. Okay, so first question about the weather conditions and the wind speeds mainly. So we have rated the aircraft to up to 14 knots wind, and we have actually tested it in real life. We have had the fortune to be able to fly both in Cornwall, well, mainly in Cornwall. We have had like really strong wind conditions, up to 40 knots and up to 20 knots crosswinds. With respect to the runway in use, and it's been fine. Like, to be honest, the flight controller copes with that very well. and the rudders, the size of the rudders and the vertical surfaces is quite big. So it has a lot of authority to cope with those conditions.
Thank you. And there's a question now for Andrew. Sorry, it's for both Andrew and Dougie, I think. So I'll put it to both of you. It's what could be the next steps? For Andrew, first of all, it's the Ampaire Cessna at the moment. What would develop, all goes well, we hope, what would develop after that?
The obvious attention is to larger aeroplanes, so ones that are more useful in terms of passenger carrying capacity. And the obvious next step is something like a 9-seater, which obviously includes the Islander and similar size aircraft, which in Orkney you'll be very familiar with. And so that's probably where our focus will be next in the phase 3 of the project, is on the Islander and that type of aircraft, with one eye also on the Twin Otter, which is a gas turbine aircraft as well, and therefore more powerful. But the engine that's in the Islander is exactly the same engine that's in the back of the Cessna 337. So we kind of know where we are in terms of power delivery. It's just managing the electrical system and where to put the battery.
I have a further question for you, just coming from Leslie Berger, who asks about the comparison of weight between, on the one hand, the weight of the engine removed from the Cessna, and on the other hand, the weight of the battery and the electric motor combined.
Yeah, while we save weight by getting rid of the internal combustion engine, the battery is much, much heavier than the engine. So at the moment, the payload is limited with the kind of battery technology that we're demonstrating. The current battery, the one that flew in Orkney, is 5 years old, and you're probably aware how quickly battery technology has moved on. Although it's fair to say that the price has come down faster than the power density. But for a pure electric Islander, it's probably going to be 10, 15 years before battery technology allows us to get a pure electric aircraft with the same payload. But in the meantime, a hybrid one with lower costs, less environmental impact, and a different business model might still be useful.
Thank you, Andrew, and we'll come back in a moment, but now across to Dougie about the next steps. And the question is, we've seen in Orkney over time, EMEX sites attracting a range of companies with marine renewable energy devices with Wave and Tide. Do you see this as a possibility that Kirkwall Airport might similarly attract a growing number of interested people?
Yes, I mean that is the aim. I suppose from a next step point of view, there's two parts to it. The first one is further integration of different types of alternatively fueled aircraft operating at the same time at the airport along with the commercial operations. So it'll be further testing of that, and then a second part is to not just make the aircraft themselves net carbon zero, but also the whole airfield infrastructure. So yes, there's really two strands to the type of testing we're looking to do. First is the aircraft themselves and how do we integrate them, and the second part is how do we make the actual airport itself net carbon zero.
If I can just add something there, that the word sustainable in the project title has two meanings. One is the environmental side of it. Of course, it has to be sustainable from the environmental side, but also from a sustainable business side. So it has to wash its face, to use a common phrase, in terms of income, and that means a long-term broad approach to alternative types of transport and the airport operations.
Thank you. And now, Herman, back to you. A question about freight. And at the moment, you're starting with health supplies. How much potential is there for, on the one hand, expanding the payload, raising the payload, and on the other hand, expanding the frequency of deliveries? And the questioner said they're interested, for example, you have a situation with island shops that could well benefit from deliveries like this.
Yeah, well, there's definitely a big scope for that. So, I mean, currently we have only 100-kilogram payload, but part of the design team is looking into a bigger aircraft that can potentially, we believe, we can take up to 400-kilogram payload. The difficulty comes when you go above, say, 600-kilogram maximum takeoff weight because of all the certification processes that it comes to it. comes with increasing the payload above that. Also, well, about the frequency, once we start reducing the amount of manpower that is required to operate one of these things, I think we with a small crew, we will be able to do several trips in one day to several places, or have, say, 3 or 4 of these aircraft based at Kirkwall, just having like this star type of distribution to all the islands and then coming back. I think initially, yeah, it will be benefiting more like the health services, but as it becomes sustainable as a business model, it will be accessible to commercial use.
There was also a question that came earlier about internet control, and it was when it happened to Andrew that the listener suddenly said, "What if you lose internet?"
Okay, so, well, I mean, the aircraft it has been equipped with all sorts of fail-safe mechanisms. So what happens if it loses connection with the ground station? Currently, we have a crew on each of the locations where it takes off, and then when it lands. But the capability has been already put in the system, so there's no need for collocated crews. The amount of data that is required to control the aircraft is also very low. We're talking about kilobits instead of like megabytes. That is what we are using right now to stream this video. Like, we're talking about really small messages, because what you need to send to the aircraft is really short instructions. Go to this waypoint, return, go here, go there. It's really short frames of text. So you don't need these strong internet connections to get to it.
And also a question about the landing arrangements. Does it just need one person in place to handle all the arrangements for the landing? Yes, correct. It only requires one person. Currently, we have a 2-people crew. That is mainly because of regulatory things that we need to have this 2-people crew there. But it's only one person that can make the decision, that really looks at the runway, makes sure that the runway is clear, that the wind is within the limits, and that there is like ATC clearance where required, and then that person can basically click the button, yeah, you're good to land, and say if cattle comes and crosses the runway during the final, then that person can also go and cancel the takeoff, and the aircraft automatically will do a go around. Pentland 284 has been back, and I think this is one for you, Herman. The question is, what is the potential for using hydrogen for these aircraft? So I'm assuming that this is a question for drones. Well, that is in the agenda, and currently we have part of our team working on looking at all the commercial solutions for propulsion that is either powered by hydrogen and that is powered electric. We're looking into that. I don't have an exact answer right now when this is going to happen, but yeah, we know that it's our responsibility to start evolving the system into sustainable, more sustainable, more green propulsion systems. So yes, we're working on that. And back to Andrew, you spoke a moment ago about the pace at which batteries are becoming more powerful and lighter. Are there any other areas of technology that we should be watching just now where either progress is underway or where progress is needed to be made?
Well, I think it actually comes back to that previous question. It's hydrogen fuel cells. So my personal view is that there will be a need for both electric and hydrogen powered aircraft, depending on the mission profile, for example, and for local infrastructure. So in Orkney, you've got the hydrolyzer plant at ED, so you've got hydrogen on tap almost, but a lot of places won't have that. And batteries are not the silver bullet, because there's some interesting chemicals in there that aren't abundant, and recycling them is difficult. So I think it will be horses for courses, and matching electric and hydrogen and sustainable aviation fuel in a transport mix is going to be one of the interesting things, especially when you're balancing things like hydrogen against domestic use for heating and that sort of thing. So aviation will be a small part of that pie, and it needs a national policy to cope with all these various demands.
And a brief question for each of you to round off. We've heard in recent months, recent years, about people being a bit embarrassed sometimes about admitting they've been flying with the issue about climate change. But does the present project give you some feeling of optimism for aviation in the future?
Well, absolutely. Yeah, I wouldn't say anything else given my job title, but no, I think it's been described as the third revolution in aviation, and I've been in aviation for over 35 years now, and it genuinely does feel like that. It's exciting young graduates and young engineers to do things differently, to take a different approach. It's challenging the way we've done things in the past. So this is all good, and it's going to keep me entertained for quite a while to come, and it will result in a different way of flying.
And Herman?
Well, yeah, definitely. We see very exciting ways on how the aviation is changing and how everything is being shaped towards the future. And I'm going to talk from my point of view, which is I work a lot with the CAA on the regulatory side of things, and they have definitely evolved into a more open. They have a more open view to try to allow all these new technologies to use part of the UK airspace and to take UK back into the lead of the aviation worldwide. So yeah, I'm pretty excited on how the future is looking.
And Dougie?
Yeah, I agree with Andrew, man. It's definitely a step change in aviation, and what the thing I find that means that it actually will happen is that it has backing at the highest levels. Government wants this change in aviation, and in the Highlands we need this change in aviation. So I absolutely think it will come to pass. And Andrew's right; it's the most exciting time I've spent in aviation. Challenging but exciting.
To Dougie, to Andrew, to Herman, thank you very much indeed for giving us this news and updates of development where Kirkwall Airport is in the front line of the aim to fly sustainably in the future. Thank you to all three of you. Thank you to our technical team for running everything so smoothly behind the scenes. And thank you, of course, to viewers and people sending in questions. We'll be back with more from the Aviation Festival at 4 o'clock when we'll be looking to the future with Loganair. We'll be hearing about their development plans from Andy Smith, the airline's head of sustainability strategy. In the meantime, from us all, goodbye for now.